When a force is applied to a spring, the spring stretches. We call this stretch the extension. In this investigation, we want to find out how the extension of a spring changes when we increase the applied force. First, we set up a simple practical using a retort stand, a clamp, a spring, a ruler, and a set of weights. We measure the original length of the spring before any force is added. Then we add a small weight and measure the new length. The difference between the original length and the new length is the extension. We keep adding weights one at a time and measure the extension each time. As the force increases, the extension increases as well. Once we have our results, we record them in a table and then plot a graph of force on the vertical axis and extension on the horizontal axis. If the spring obeys Hooke's law, the graph will be a straight line through the origin. This means the extension is directly proportional to the force. The slope or gradient of the line shows the spring constant. A bigger gradient means the spring stretches easily. A smaller gradient means the spring is stiffer. If the spring is stretched too far, it reaches its limit of proportionality. After this point, the graph curves, and the spring no longer obeys Hooke's law. This means further force will not produce proportional extension, and the spring may not return to its original length. By completing this investigation, we learn how springs behave, how force and extension are linked, and why Hooke's law is useful in engineering and everyday life.